Hi SecurityTube, welcome to part 10 of the Wireless LAN Security Mega Primer. In this video, we will look at how to hack isolated Wi-Fi clients. So before we begin, let's understand a little bit about how client softwares work. So let's say we have a laptop, which is actually the wireless client, and there is an access point with an SSID default. Now, this is the first time both of these are in the RF vicinity and client is about to connect to SSID default. Now the user clicks on connect to default and the connection happens. The moment this happens, SSID default is added to the preferred network list in the client. What does this mean? Well, the preferred network list are networks to which the client can automatically connect to in the future whenever the network is available in the vicinity. So what would happen is the next time client is anywhere near the SSID default, it would automatically initiate a connection without prompting the user. Now, this is actually a screenshot from a Windows machine. Every operating system would have its own version of how this would work. Anyway, what happens over time is as a client keeps connecting to more and more access points with different SSIDs, a huge list of SSIDs and credentials wherever applicable, that is whenever the network is encrypted with WEP or WPA, is actually created on the client machine. So now what really happens when the client is roaming and is isolated? What do we mean by that? So let's assume now this client is actually at an airport where none of the networks it had previously connected to, such as default, SecurityTube, Office or T-Mobile, are available. Now what happens is the client keeps on sending out probe request packets. Now as we know, probe request packets is a way of trying to find whether a given network is available in the vicinity. Right? So the client would automatically keep sending probe requests to locate any of these networks which have been previously stored in its preferred network list. Now let's try and look at this behavior. So we'll go to our backtrack instance and we already have our monitor mode interface created up and running. So what we will do is, let me actually run arrow dump and let it actually scan through the various channels. So this is kind of going on and looking right now, and in the meantime I will go ahead and take out our friendly little machine, which is my iPhone, which is our little guinea pig for the time being for Wi-Fi. So just a second, let me dim the brightness so that I can actually show you something here. And now if you notice, I've enabled the Wi-Fi interface and it is searching for various networks, and here is the iPhone, right? This is my iPhone, and if you notice, it is actually searching for 3 networks: SecurityTube, Wireless Lab and Vivek with a capital V, right? So if we kind of go back to our presentation, this is exactly what the client is doing. Now previously my iPhone had connected to SecurityTube, Vivek and Wireless Lab, and these network profiles were stored in it. And now when it is all isolated, when none of these networks are available around, then it is still continuously sending these probe requests. Please note that SSID is case sensitive. So a capital V Vivek and a small v Vivek are different. So now coming back, we can also analyze the behavior using Wireshark. So let me actually run Wireshark. The reason I stress on using Wireshark more and more is the day you start understanding things at a packet level, you can never go wrong in network security. I mean, whatever you think, if you see that in packets, you're absolutely bang on target. So I would always say use Wireshark. That is the best way you can learn computer security. So I've started sniffing on WLAN 0 and I'm starting to see some packets here. Now what we are really interested in is basically this roaming client, and I'm very sure a lot of packets have already gone through. So what we will do is, let's actually go back here and take the MAC address of the client. So this is my iPhone MAC address, and let me stop the sniffing and just add a quick filter for wlan.addr equals the MAC address of my clients. Let me stop this, apply the filter, and what we are really interested in is the probe request packets. Now if you notice, this is my Apple machine which is actually sending these probe request packets out to the network. We also see some probe responses. This is from nearby APs, but the important thing is we have a probe request for SecurityTube. We have a null probe request to actually look at what access points are available in the vicinity. Here is another probe request for Vivek with a capital V, and here are probe requests from my iPhone for wireless lab, and this is exactly what we are able to see here. Awesome, right? So this is how we can correlate a lot of this output with actually what is happening in the air. Now let's go back to our presentation. So the question arises, well, is this really a consistent behavior? Now the point to note here is different operating systems may behave differently, and even different service packs, for example in Windows, may behave differently. What do I mean by that? Well, what happened is this behavior has been exploited for a very long time, I guess for the last 7 to 8 years, to such an extent that OS manufacturers have gotten on guard. And this is where a lot of times, as an example, let's say if you've connected to an open access point with no authentication, the next time you try, or even you are in the vicinity of the same access point, your client may not automatically connect. It would want you to actually do a connection manually so as to know that you are actually really wanting to connect to that insecure open authentication, no encryption access point, right? So I am not going to really go through the behavior of different operating systems and all, simply because that's a topic in itself. And here's the interesting thing, with whatever we have learned till now with Wireshark, and by just going ahead and looking at how your operating system is sending probe requests for different networks you have previously connected to, you can derive this behavior yourself, right? So you have the tools, go ahead, more power to you. Now, as you can imagine, there are multiple cases possible for any given network which is stored in the client. Now this stored network, like default as we just saw in the slides before, could have one of the following configurations. Either it can have no encryption, maybe it is web protected, or maybe it has WPA or WPA2. Now in each of these cases, to actually hack the client, different ways or different techniques would be required. We'll take up case 1. Right? Case 1 is there is open authentication and no encryption at all for the given SSID. What that means is the victim has, as an example, an SSID stored called SecurityTube, and this network does not have any encryption, it's simple open authentication. Now let us understand how an attacker would go ahead and take advantage of such a stored network. So as we've seen previously, the client is going to be sending out broadcast probe requests for SecurityTube. The attacker will be patiently sniffing and respond back with a probe response for SecurityTube, emulating a legitimate access point with SSID SecurityTube. Now the victim is happy that it's actually found the SecurityTube network in the vicinity, and it sends an authentication request to which the attacker would simply send an authentication success message. Then the association phase goes through very simply, and then data exchange happens. Now you may ask me, how is this even possible? Right? The attacker is not really a real access point at all. Why is the client accepting the probe response? So here is the fundamental problem. In Wi-Fi, currently the client is not trying to authenticate the access point in any way. If it sees an SSID anywhere in the air, wherever it might be, it just blindly believes that this is the actual infrastructure network it had connected to previously. So here is the hack. Anyone can set up a similar SSID based on what the client is currently probing for and force the client to connect to them, right? And this, as one can imagine, would be especially true in the case of hotspot SSIDs, which almost by definition have open authentication and no encryption at all. So now let's go to a demo and look at how all of this would work. So this is what we observed in the previous run of AeroDump. My iPhone is actually searching for 3 networks: SecurityTube, Wireless Lab and Vivek, right? Now here is what we are going to do. We will set up a fake access point called SecurityTube and see what the client does. So our friend Airbase NG comes to our help here. So we'll say Airbase NG --ESSID. Let's say we give it as SecurityTube, the network we want to broadcast, and let's also give some other interesting options. Let's also change the MAC address of the access point to all A's. Right? And let's launch this network. So now we have an access point with MAC address all A's. Right? Now let's go back to our Wireshark and add another filter for wlan.addr equals AA and apply. Right? Now let's go back here and see what happens. I'm starting my client up once again, and if you notice, right now it actually detects that the network SecurityTube is around, right? And if you notice, the client has automatically connected to the network SecurityTube. This is very, I cannot stress further, worrisome. Simply because now, even without me doing anything, my iPhone has connected to a foreign network. And by the way, this is something almost pretty much all manufacturers of Wi-Fi clients do, whether they are operating systems running on your Macs or PCs or whatever. Of course, there are a lot of safeguards built on top of it. As an example, at times, even when I connect back to the authorized network on my Mac, it prompts me for a username, for a password to allow it to do so. Anyway, here is the problem area, is that now, first what we have done is we figured out what are the networks the client is probing for, and then we have gone ahead and created a Wi-Fi network with that same ESSID, and the Wi-Fi client has automatically associated with us. Now, as in the previous video when we talked about hotspot attacks, the client would be on an auto configuration IP address right now, which we can find and access by looking at the packets. using the AT0 interface. Alternately, we could also have provided a DHCP based address. Anyway, so let's concentrate on just this hack. Now this is one case in which we can go ahead and probably figure out an SSID which the client is probing for and then create an access point with that AP. Now, one of the interesting things, if you're really kind of curious as to what are the things happening, is you could use this with the -v option. The -v option is for verbose, which actually tells you what is happening currently. If you notice, got directed probe for a particular client, and if you kind of scroll up there, you may even notice that the client got associated automatically, right? So this gives you a little bit more information about what is happening over the air, or what actually Airbase NG is doing. Now let's do something interesting. If you noticed, it was a bit painful to figure out what is this SSID, then create an access point for it and whatnot. Well, can't we just tell Airbase to respond to every probe request from any client it is seeing over the air? Would that not be fun? Well, great. The Aircrack NG team decided to build that functionality into it, and that saves us a lot of time. So let me just hit Airbase NG, and what we are really interested in here is the -p option, which is very, very interesting. It says respond to all probes even when specifying ESSIDs. When you specify an ESSID, basically you go ahead and bind it to one, but in this case it will respond to all probes. And one of the other interesting things also which we can do is enable beacons for the probed SSID values. What this will do is this will actually start sending out beacon frames whenever it is responding to a particular ESSID value for that value. As an example, when it sees a probe request coming in for SecurityTube, it will respond with a probe response and also send out a couple of beacon frames as if to announce that it's a real access point, right? Very, very interesting. So let me do the following. Let me actually use the -p option. There is actually a better option here. I'll just tell you in a second which one that is. Okay, this was the only option. -p, then you have -c. I guess you could practically just go ahead and set 10, and then after that we could give the monitor mode interface. Let's just first give the access point MAC address and then the monitor mode interface. Right, awesome. Now let's just make it a little bit more interactive. Maybe verbose mode would tell us a lot about which probe requests it is really responding to, right? So if you notice, got directed probe for Vivek, and now notice something interesting on the screen here. Can you see that all of a sudden all these networks have come alive? Well, it's connected to SecurityTube, but also Capital Vivek and Wireless Lab also seems to be there. And if you notice, the client is now hopping between these various access points, and all of these are spurious access points which we've set up. And the client is connected to Vivek, now back to SecurityTube and all of that. So here is what is interestingly happening. The client has 3 networks stored in its PNL. One is SecurityTube, the other is Vivek, and the third is Wireless Lab. Now the client is sending out these probe requests for all of these networks. And what is happening is the Airbase NG tool is responding with probe responses and also with the respective beacon frames. So the client is getting confused, and it actually feels all of these networks are actually existing because of the beacon frames as well as the probe responses. And anytime it's getting a beacon frame from a particular network, of course it stops getting from other networks. So it feels it has a better access point available because of higher signal strength, and it goes ahead and hops onto it. funny. It's almost like a little dance. Can you see that? It's kind of moving from wireless lab to Vivek to SecurityTube, just kind of dancing all around. Anyway, so let's kind of kill it. So we can make our iPhone stop dancing. And if you had actually gone ahead and captured all the packets, which we haven't, then you could see this entire dance live, right? I mean, sometimes I love this subject so much, I could just like spend sleepless nights doing all these experiments. When you see all of these interesting things happening, it just, I mean, what do I say? You just get so enthusiastic and so thrilled about it that you just keep on experimenting. Anyway, I'll leave the interpretation of these packets to you. Very simply, you would notice that there would be a lot of probe request, probe response pairs, which is kind of going by, which is actually helping us simulate all of these networks which are up there. Right? So once again, here is the interesting cool thing. And here is our little dance. Try this out yourself. As I said, different operating systems would end up doing this in a very different way. But what we are doing is, on the client, any access point or any SSID which was ever configured and used, and the client is actively searching for it, would end up getting exposed in the probe requests, and Airbase NG would emulate an access point in the vicinity for that specific ESSID, and your client would automatically end up connecting to it. What you would notice is behavior in XP, Vista, and all of these things may differ. On the Mac it may be different, but there are a lot of things here which anybody could exploit. And as you know, once the client has connected to you and you have IP level connectivity, well, Nmap and Metasploit autopon. Need I say more? Coming back, so the fundamental problem, as we said, is, well, the client has no way of knowing whether the access point it is connecting to is the real authorized access point or not. The ESSID is a very weak parameter to base this trust on, simply because the ESSID is trivial to replicate. I mean, to an extent where anyone with an access point software could have been doing the exact same hack we did. Now comes case 2 and 3, which is what happens if the access point which was currently stored in the PNL or the preferred network list is using WEP or WPA, WPA2, or even shared key authentication as an example, right? Now we will talk about all of these cases. Please don't worry, we'll take up these cases, but a little later, after we finish first talking about encryption and cracking different encryption mechanisms in wireless, right? So hold on, I haven't forgotten about these cases. We will take them up. I think a couple of questions had also come in the hotspot video, where people had asked about what would happen in the case of WEP and WPA, WPA2 based hotspots. Well, I wouldn't call them hotspots, but I mean, okay, access points, right? We can do a lot of things. Of course, the open and no auth case is the best case, where you can attack the client immediately once it connects to it. But things are possible in WEP and in WPA, WPA2 as well. We'll explore them in later videos. Okay, that's all for this video. Hope you enjoyed it. Please leave your comments behind like always. I love reading them. And as I said, nothing encourages me more than people actually using and benefiting from these videos. So I'll keep making them. There'll be no stopping me at all. Right? Okay, thank you. Bye-bye.